Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. In this video, doing some review for that systems quiz, and so make sure you're taking it one step at a time. So first, what we're going to do is graph that system in the same coordinate plane, identify that solution, that's where they cross, and then we're going to check algebraically to make sure that the solutions work out for both equations. And so we have two equations, and so make sure you're using two different colors. So first I'm going to say, all right, first equation, y equals negative 2x plus 8. So I'm going to use that y-intercept of 8, so that means on my y-axis I plot that point of 0, 8, and then I can use that slope of negative 2. I can rewrite it as a fraction where it's negative 2 over 1, and so that just says I'm going to go down 2 and to the right 1. So again, make sure you're using those keywords for yourself, and I can kind of build that staircase. So I go down 2 and to the right 1 to get my next order pair. Then I can use that wonderful straight edge, draw through those 2 points. I have my linear function. So again, notice I have my y-intercept, I have my slope, and so I'm good. Then I can have my second equation at the point 0, 1 is going to be our y-intercept, and then we're going to use that slope. So we're going to say we go 1 up and 3 to the right. So we go 1 up and 3 to the right, and so we're going to say once we have that point, then we can draw our line through those points. And so we're going to say, all right, once I have through those 2 points, draw your line. And so if you notice, we're saying, hey, where does that go through? Well, if you need to redraw it, it should be going down 2 to the right 1 for each of those points. And if you notice, both of those equations go through that point of 3, 2. So we're going to say that solution for our system of equations is going to be, again, remember x value first, then your y value. So we're going to say 3, 2 is going to be that order pair. And so how can we check that? Well, again, use those values to check algebraically. So we're going to say, all right, in the equation negative 2x plus 8, we're going to use that solution point of 3, 2. And so we're going to plug in where x equals 3, our y value should be 2. So we're saying, all right, does 2 equal, and we have negative 2 times our x value, which is 3, and then plus 8. So again, make sure you're using that equation from above. Make sure you can simplify first. So we're going to say negative 2 times 3 is going to be negative 6 plus 8. We're saying, is this equal to 2? Well, you better believe it. So we have negative 6 plus 8 is going to be 2, which is equal to 2. So we know that one works. And also too, we can check to see if that second equation, y equals 1/3 x plus 1, do we get the order pair 3, 2? When x equals 3, does our y value equal 2? So we have 2 is equal to, and then we have 1/3 times 3 plus 1. And make sure you're multiplying those fractions carefully. If you need to, you can write that 3 over 1, multiply numerators. 3 times 3 is 1. And 3 divided by 3 is, 3 times 1 is 3 for both our numerator and our denominator. So we're going to say 2 is equal to 1 plus 1, which works out. So we're going to say, since both sides of those equations are correct and the same value, we know that that is a solution point. So now on the back, a similar setup. Make sure you can read through those directions. First, want to graph that system, same coordinate plane. So we're going to be using this table, and we're going to be using the equation given. And we're going to see, okay, where do they line up? Then we want to say, okay, can we identify that type of solution? Meaning it's either going to have one solution, meaning that's where they cross. It has no solutions, meaning they're parallel lines, or it has infinitely many solutions, meaning they are the same line that overlap. And we want to make sure that we can explain why we chose that choice. So one thing at a time, let's go ahead and graph these out. So let's see, I have this table, find the things we need first. So I have, what is my change in y? Well, I am going down, so I'm decreasing by 2, where my change in x is going to be plus 1. And I can also notice too, hey, my y-intercept is negative 3. So I'm going to say for this first one, plot that y-intercept at -3. That's at point 0, -3. And then I can say I go down 2 and to the right 1. So again, use that change in y over that change in x for your slope. So I go down 2 to the right 1, have my next order pair. And again, if you need to, go to pick out a couple more points, down 2 to the right 1, build that staircase, and draw your line through those points. Again, they should form a straight line, otherwise it's not going to be a linear function. So once I have those through those points, then I could say, okay, take my second equation, so I have y equals -2x minus 6. So I have to plot that point of 0, -6. It's going to be my y-intercept, and then use your slope, so I have -2 over 1, same kind of stuff actually. So we're going to say we go down 2 and to the right 1 for that red function. And if you notice, as I plot these points and draw the line through those points, you're going to say, hey, those two functions are actually parallel. So I'm going to say that they do not have a solution since they are parallel lines. So I'm going to say I can't identify a solution because they don't cross at any point. And we're going to say the type of solution is no solution. And so make sure you can kind of explain how that works. So we're going to say the system has no solution since the lines are parallel. Again, not only are they parallel, but they have this a different y-intercept. So since they're same slope but different y-intercept, that's how we know that they're going to have no solution. And then the last concept we're going to go through is being able to distinguish whether that is going to be a linear function or a non-linear function. So kind of remember how this works. Again, a straight line is linear, so straight line. And a non-linear means it's not going to be a straight line. So when you're given the picture, like you are for the graphs, you can say, hey, very easily you can identify those types of functions. So you're going to say, hey, I know for 1, that's a nice, easy straight line, so this is going to be linear. However, for 2, you notice, hey, I have a curve on that line. It kind of goes through those points, and so we're going to say this is going to be non-linear. So that's not a straight line, meaning it's going to be non-linear. However, for 3 and 4, those are both linear since those have those straight lines. And also, too, you can kind of remember for number 1, we can say y equals mx plus b is that type of equation. However, for 3 and 4, we can say it's y equals a value as that is straight horizontal line. In that part B, make sure you're saying, okay, going from those pictures to the table, we're trying to see, okay, what type of function do we have? Do we have nonlinear? Do we have linear? So it should be the same rate of change, meaning it should be the same slope from each point. So let's kind of figure out what we have in each table. So we have in table number 5, we're saying, okay, what's our change in y? Well, it's going down 3. And that is true for that next point too. So since it has that same change in y, let's check that change in x. It's increasing by 1 for each step. So always looking for this. So looking for same rate of change. And that's just talking about that slope. So it should be the same slope for it to be linear. So for number 5, or for table number 5, we'll say this is going to be a linear function. However, in that table number 6, let's check it out. If we notice, we go from one point to the next, we're saying we go down 5. And if you notice, it is now increasing by 5. So what happened here? Well, however, the change in x is still the same. So since we have a different change in y from one point to the next, we can say this table is going to be non-linear, or this function is going to be non-linear. So just make sure that you're saying, okay, look at that rate of change, meaning the slope, it should be the same from one point to the next. And then if you're given an equation in part C, we're going to say, okay, look at that degree or the power of x. So we're going to look at degree or power of x. And we should know this. We should say, hey, is that power of x? It's so let's say look at degree or power of x, and we want to say linear is power of 1, meaning that exponent should just be a 1, or there should be nothing there because we're saying it's going to be a straight line. Make sure you can say this. So we have in equation number 7, we're going to say y equals x squared plus 3. Notice how that exponent is 2. So we're going to say, hey, this is actually going to be a non-linear function. It's going to be a curved line, where in equation number 8, we can actually say that is going to be a straight line since it is a power of 1. So what you want to do here at the bottom is group those different representations. We can say, hey, which one of those were linear functions? Well, if I go back up to the top, I can say, hey, I have 1, 3, 4. Those are all linear functions. I can say, let's have 1, 3, 4. Those are all linear functions. And then 5 and 8. So 5 and 8 were all linear functions. However, for those other representations, we can say those are non-linear functions. So graph number 2, we had table number 6, and equation number 7. Those were all examples of non-linear functions. So to repeat what we kind of had, for it to be a straight line, that's when it's a linear function. Not a straight line, non-linear function. For a table, it has to be the same rate of change. Otherwise, it's going to be non-linear. And then lastly, for that degree or power of x, it has to be 1, or I guess it could be 0 if we have, a horizontal line. Otherwise, it's going to be non-linear. Again, be sure to pause, hit rewind, and as always, super slam that subscribe button.